Alright, so in example 4, we got all this data, the daily energy demand for megawatt hours in the month of July. Alright, so that's how they calculate the usage. Alright, and in this problem, we're going to calculate our mean and our sigma. Okay, so if you have graphing calculator, follow step 1 and 2. If not, plug into Desmos. Okay. Okay, so when you plug in Desmos, it calculates it for you very nicely. The longest part is probably just plugging in all the data points. So the average data usage is 44.65 megawatt hours. And then our standard deviation of the data is 6.07. Alright, and then we'll just move on to example 5. So same thing, we're going to organize your data. And we find the mean. So the first thing I'm going to do is I'm going to rewrite everything. You got 37, 37, lowest to highest. So we got 41 done, and then it goes 42, 43, 46, and 89. Alright, plug this list into Desmos, and Desmos will calculate the mean to be 44.82. The standard deviation calculated in Desmos is 14.21. And then identify any outliers. I'm going to say 89. And that's probably because it's almost doubled 46. Alright, so 89 is definitely a huge outlier there. And then we describe how the outlier affects the mean. Alright, so I'm going to just cut this into 2 columns. Oops, sorry. Alright, pause, back in action. So I'm going to say with 89 minutes. Okay, we calculated our mean to be 44.82, and our standard deviation is 14.21. If you go back into Desmos and you recalculate it without, okay, Desmos calculates the mean to be 40.4, which is drastic because you're going from 44.82 megawatt, or I'm sorry, wrong problem, 44.82 minutes is the average for doubling times, and then it becomes 40.4. So that means this research lab of virus growing is doubling faster. And the standard deviation becomes 2.69, and that's the huge jump between 14.21 and 2.69. Okay.